Worry. Oh my god. I didn't get the music playing. Uh, 1 minute. I'm trying to figure out if I mess up my YouTube stream. Zach, hope you're doing well. I think I accidentally like double tapped start and stop on YouTube, and I'm concerned that I messed something up. So I'm trying to make sure that I didn't mess it up. I don't know. The stream was running for a minute. I was like quickly finishing up some dishes while I was letting the starting soon screen run. If I could just look at my channel and see that I am live, I'll be satisfied, I guess. Okay, I am live. Okay. What am I doing? I guess we're gonna do settings. So Saturday streams are back to being regular math help now. Because the general relativity just became too much and we were near the end of it anyway, so I called it off a little like prematurely. And I need to remember how the hell these normal math streams work because I've been doing so much of the reading groups and then collaborations that I feel like I hardly haven't been doing this the past like month or two. Classical streaming, all the other things you've done that. Yeah. I was like just scrambling around to make a second like tiny cup of coffee because I want to use the last of my beans, and then I want to like clean up after that. Slim, thank you so much for the raid. Also, hi Jasu. I hope your stream was good, Slim. I was working on you a bit, doing those the stuff with the quintic formula and why there isn't one. Or yeah, quintic. Hey Rex. Yeah, I hope that went well. From proving the result. Oh, okay, fair enough. You'll get it one day. Yeah, for anyone who's just hopping in, Saturdays have been general relativity days until today. So I decided to end the reading group, so we're just kind of back to Saturdays being in a normal math stream. This is kind of how I want them anyway. Human relativity, come back to complex. Next is differential geometry, and then some Riemannian geometry. Finally, get a revenge on relativity. Basically, even then, I don't know what point we actually learned something that is actually general relativity, because like the book, I don't even know when they introduced tensors, but it's really late in the book, so we were just doing differential geometry. And so I still feel a little bit confused about that entire thing. Make diplomas? No. Hey, $5. 25. Oh my god. I feel like in order to give out a diploma in something, I should actually understand that thing for myself, and I certainly don't. Naman. Oh, you retracted it. Never mind. Okay, we're probably going to do some complex integration, though. You have diploma plus regalia after taking 10 Twitch reading groups. Hey, Naman. Oh no, I think you have me backwards. Uh, I generally dislike number theory, and so the deal with that stream was Slim or Academy's Ideas was trying to convince me that it's not so bad, and it was at least a partial success. I feel like I moved a little bit in that direction. You need a Medal of Valor, Rex. I like that spirit. What am I doing? It was sarcasm. Oh, okay. Number theory is the motivation for complex. I guess with generating functions? Or like what's the connection there? I'm trying to remember how to do something, but I can't remember what the something is now. I seriously don't remember what I was trying to find out. Okay, well, let's just dive into a problem then. Let's look at part B. I think I did A. I don't think we did C. But we're gonna start with B. We're reading Introduction to University Maths instead of writing your thesis. You know, that sounds like the perfect distraction, Jasu. Dude, I feel like I'm not gonna be mentally in it today. I'm looking at this and just drawing a blank right now. How do we deal with cosine? We have to we replace it with e to the ikx. Oh no, but k is whatever is the coefficient of cosine. Hey Obi. You always pop it in for the ODE mention. Don Sliman's actions that have solving qual problems. um I definitely have been guilty of having like a Zach streamer, someone on one monitor, the textbook I'm supposed to be reading on the other monitor, and doing zero reading. Okay, so we're gonna use. Okay, this is starting to come back to me now. Oh, was Famous Sean? I follow him. I didn't catch him being on though. Was he actually streaming math? I think I've seen him streaming like Fortnite or something. You should start streaming regardless, Destin, if you're interested. And if you do, I would happily shout you out and stuff. Yeah, I'm planning to do a little like refresher on differential equations. I'd like to learn like existence and uniqueness for ODEs. And then like just kind of remind myself of ODEs in general with how they work, and then do a little bit, try to introduce myself to a bit more to like PDEs in the next like month or so. My study of very elementary number theory is mind-boggling to me. Can you imagine how it went for you? Study about base number systems. Ooh, I mean that's, I wouldn't call that. I guess it depends how deep you went, but different bases can be pretty difficult. It's like 5 hours ago. Oh, I might have been in bed, to be honest, 5 hours ago. Actually, no, I wasn't. I got out of bed at a decent time. Deltarune. Okay, okay. IRS isn't real. Hey, Eldritch. VED. Indefinite integration. We can talk about that. Yeah, and so like learning how to do like addition and multiplication and binary is kind of a trip. And I definitely wouldn't call it easy, although it is like, you could call it like basic in the sense that it's very like fundamental, but I wouldn't call it easy. You two tried to prepare for graduate school the summer before. It's nigh impossible. Yeah, I'm not expecting to learn everything, but like I'm very stressed about like succeeding in grad school, so at least for the stuff that I can control, I'm trying to control it. The stuff I can't control, you know, it's the best that you can do, but is indefinite integration limit as x goes to 0 thing? No. Not necessarily. So the short answer is that this is an indefinite integral, and this is a definite integral. And so the only difference are the bounds. And so let's like talk about what this actually means. For a definite integral, you have some generic function f of x. What the bounds from a to b are doing are they're saying your start and end points for the area under the curve. So like this might be x equals a, and this over here might be x equals b. This definite integral will get you the area underneath f of x from one endpoint to the other. They're real numbers, Jasu. I don't want to get too deep into being precisely, or into being precise here, but indefinite integral is also called the antiderivative. Yeah. And so the indefinite integral is it doesn't have as direct of an interpretation like that. It's basically just the antiderivative, as Obi says. It kind of gets you like a more general function that we often call capital X plus some constant. And they're both fundamentally doing the same thing. So you could think of this as a definite integral if you think instead about the integral from 0 to x of f of x dx, but it's bad form to repeat x in the bounds and as your variable, so we often use what's called a dummy variable. And so these aren't quite the same exact thing, but they're very close to each other. The only difference is that plus c thing. It's very fundamentalist of me. Wait, what part? Dummy variable controls how stupid I act in social situations. Yes, and you always want that at the supremum or maximum. Oh, there. Oh, I get it. Ha. Actually, I guess they are the same thing if f of 0 is your c. But Ved, how I think of it personally is the definite integral is just a number, and that number represents this area down here, whereas the indefinite integral represents a function that is the antiderivative. Like if you take the derivative of this thing, you get the inside of the integral back. They're still fundamentally both integration, just kind of viewed through different lenses, or like for different purposes. So I hope that helps, Fed. Let me know if that's what you were trying to get at. If you want to talk about limits, that usually comes up in improper integrals. Just to kind of set the record straight on that part. So like a good example of that would be the integral of 1 over x dx from, say, -1 to 1. And this is called improper because there's an asymptote at 0, and we're crossing right over that. So like 1 over x looks like this. And so if you want to integrate from -1 to +1, you're crossing right over that vertical asymptote there. And so in order to deal with that, that's when you bring in the idea of a limit. And on Johnny, I'm sorry if I'm saying that wrong. I see your question about differential forms. I'm gonna have to look up the definition of those again, because I think I've seen them before. I just don't remember like what exactly the term is. So we'd say like the limit as a goes to 0 from the left, the integral from -1 to a 1 over x dx, plus the limit as, say, b goes to 0 from the right, integral from b to +1 of 1 over x dx. So you kind of split up into two. This integral is going to end up being undefined. But that's how you would like analyze this original integral here. Yes, Jesse, we call those improper as well. What was the word used for the region between? Yeah, we'd say that x equals 0 is an asymptote, or like a vertical asymptote. And that's why this integral is improper, because the bounds cross right over that asymptote. Oh, I mean, Zach, you can self-promote all you want as far as I'm concerned. But up to you. Honestly, I need to do a better job of promoting you all like proactively, but like I specifically have a thing down in my Twitch thing that I added like maybe 2 months ago or something, that if you're a math streamer, just promote the hell out of yourself in my stream. Let me catch up with the YouTube chat. Someone is saying, I mean, the lecture they're referring to spent 4 hours to force me not to count, as in that lecture tried to explain how base number systems were created in the first place. Sounds confusing because it is, yeah. I can see why some people won't like it all. Either you love it or you hate it. Yeah. Command for you, Poison Mouse? What would it say? Megalomorph. Oh, thank you for talking about differential forms there. So that was in response to on. I'm sorry, I'm pronouncing it wrong. On Janie. I'm wondering if they were talking about like Oh no, maybe this. Okay. So I wonder if they're talking about a different. So the differential form has a certain meaning in math, but I think like in calculus classes they often like, are you doing like related rates where like if you have like a volume of a cone, what is that? A third pi r cubed? No, pi r squared h. It's something like that. Actually, no, that's a bad example. Let's say a sphere. 4/3 pi r cubed. I think they sometimes would call the differential form uh like that. And so I wonder if that's what Anjani is talking about. Sage. Certainly, yes. You're going off to London? Have fun in London, Sage. Good luck. See you around. Naman, while the integral you showed looks hella illegal, I don't know why we can get around breaking the domain of log. It's so we wouldn't break the domain of log because the integral of 1 over x is technically ln of the absolute value of x. Well, yeah, we still have an issue with 0, but the absolute value part helps out with the negatives at least. The integral does not converge, so in that sense it's still like a bad one. But we're not violating the domain of log because the absolute value takes care of the negatives, and then the limits make it so we're not actually plugging in 0. We're just getting close. Just try not to forget you. I won't, Sage. As you tell your dad you're a good man? Okay. It's very kind of you for your dad. Hey, SB. Oh wait, so Anjani, you're saying this is what you mean by a differential form when you say yes indeed there? Exclusive this includes indefinite integral, definite integration, area under the curve, differential equations showing with indefinite integrals will get tougher than this. I mean, tougher always depends on the person. The integrals that you're going to learn about conceptually are all the same, but they often really give you really tricky integrals to actually evaluate. Hey Phobos, hope you're doing well. So they like, if you can understand conceptually what an integral is, just like the area under a curve or the antiderivative, that's kind of everything you need to know about them. The way that they make it difficult is they'll give you things that are hard to integrate, like the integral from 0 to pi over 2 of like sine squared x cosine x dx. And you have to do a lot of algebra with sine and cosine. Well, you don't actually have to do a lot of algebra in this particular example. Good night, Mouse. Oh, and I missed your comment about the thing. I can make you a command if you want. But they'll make you do a bunch of algebra with like the inside of that before you can actually integrate it. That's where it usually like gets tough. And and people in general want a fun command, like it's something that's pretty easy to do. Okay, yeah. So a differential form, or like this type of equation, honestly, I'm not even sure what the best term for it is. It basically, if you know the relationship between, like in this example, the volume of a sphere and the radius, what this, like, I'll just use your term, differential form. What this tells us is, if we were to change the radius by just a little bit, how much will the volume change? Because those things are definitely related to each other. Well, Zach, that's why I caveated it with saying the integration you're going to learn about in that class. And you can still interpret that arc length integral as the area under a different curve. And so that's what it says. So like, they'll often ask like I mean, okay, well, like root 1 plus dy by dx squared, like this integral still gets you, like, even though it's an arc length integral, wouldn't that still get you the area underneath a different function? That's what I meant. Like the area underneath this function is the arc length of another function. It's kind of cheesy to say that, but why is it always an approximation? Type answer, can it be more rigorous? I'd argue it's also the area under a curve. That's not the interesting interpretation for it, but it's the arc length of dy by dx, or it's the area underneath square root 1 plus dy by dx squared. Oh yeah, Ved. To solve, sorry, I'm talking about 3 different things at once, and that's maybe not a good way to stream about math, but that, yeah, if you wanted to solve that integral, the way you do it is like take t, to use your thing, equal to sine x, just sine, and then dt will equal cosine x dx, and then you would get u squared d, or t squared dt, and then you have to change the bounds, but I don't want to do that. So yeah, Johnny, the reason it's always an approximation is because this is only exact for infinitesimally small values of dr and dv. So you need, like, this only works for very small values of dr. And so what you could do is like, at the moment the sphere has radius 3 and the volume increases, or sorry, and the radius increases by 0.01, for instance, how much does the volume change? About. And so, like, it's the nature of the beast that this is an approximation if you try to actually plug numbers into it. And so, like, this dr, the smaller the number you plug in, the more valid this thing is. But for any number you actually plug into it, it's never going to be exactly right. It's like when you're at home trying to take care of 3 kids at once. I bet, Zach, yeah. Rigorous definition requires a lot of background. Yeah, it probably does, Slim. And so the more rigorous way of doing it is to use calculus to actually do an integral. If you wanted to get back, like you could integrate each side of this equation to get back to the original. And that's the way you would do this exactly. Like if you want to find the exact change in volume from say a radius of 2 to a radius of 3, you could do that. But if you just plug in numbers, that's why that's when it becomes a approximate. You know, sometimes when people substitute in integration, if there's a square and square root, they just cancel them without putting the mod of the value. Why is that? I might need to see like an example of that to know exactly what you're talking about, but it's usually just kind of being lazy. Like I do that too. But yeah, if you're going to claim that like this square root of x squared is equal to x, this is only true if x is greater than or equal to 0. So as soon as you say this is true, the result is only valid for certain values of x. So they're just not writing that like constraint there, but it is there in the background. Anytime studying, we have no motivations or deadlines. Try to get excited about something. Like, yeah, if you're not excited about it, then it's going to be very difficult to like stick with it. How do we integrate theta? That's a little bit too general of a question, Prithvi. Like, do you mean integration in polar coordinates? Question on the right side. Would you put sine squared as t? We could try it. I don't think it's going to... Oh wait, that might also work. 2 sine x cosine x. It's going to be more complicated if you do that. It's allowed, for sure. But you're making yourself more work here because you have a sine x cosine x here for the dx and out, so one of these signs gets taken away. So it'll be sine x times a half dt. And then to deal with this last sine x, you can make it square root t, I guess. That feels a little bit unnecessarily messy, but that's also valid. It will get you the right answer too. So Prithvi said yes to integration in polar coordinates. I would just use Paul's online notes if you want to learn that. The short answer is if you want to find the area in polar coordinates, you use this formula here, and r is a function of theta. And I would just kind of go through the example problems here, see if you can like work them out, and then look at the solution, and they're explained pretty well. Yeah, for double integrals, you're right, Jesu. I was assuming the person is learning it for the first time, and they usually only know single integrals. Okay. Dang, that was like a flurry right off the bat. Usually with these streams, it takes a minute for people to like filter in and ask questions. I'm gonna put my mug away. 1 second. Yeah, Jesu. Uh, I for the way that I was first introduced to polar coordinates, they basically take the thing that you put, but they evaluate like the 0 to R bit for you. You know, of course we should use a dummy variable, but that's all the formula is. Okay, so unless someone pops in with another question, I'm gonna go back to not even back, but I'm just gonna try and start complex analysis stuff. I need to make room. Oh wait, you know, I never use this one tool. This tool. Aha! Oh wait. Oh, that just... Really? You can't just know to put it onto the next page? Okay. Oh, no. Okay, fine. Here's what's gonna happen instead. We're gonna... Well... New page. There. Wait, come on. No, stop going down. No, I want to go up. I want to go up. Let me go up, please. Okay. Seriously? It might just be the song. I'll skip the song and tell me if it's still skipping. Because I definitely used to have an issue with my music skipping. And I thought I fixed it, but if that issue has come back, then I want to know that. It's just the track. Okay. Empire, I answered that. I just said try to find something that you're excited about. Yeah, it is a bit of a weird song. One more question. What is the meaning of C? Like, I know it is a concept of integration, though my teacher cuts marks for not writing it. Yeah, so the C is very important. And I think the easiest way of figuring that out is, or of knowing why is, the derivative of any constant is 0. So like of 2 or of, you know, pi. It's all 0. So in a sense, when you take the derivative, you kind of lose information in a way. Like if we think about the function x cubed plus 1 and the function x cubed plus 4, why not? They have the same derivative. Oops, that's not right. There we go. They have the same derivative, 3x squared. Like the 1 and the 4 both just go down to 0. So if I like, yeah, Jesse, if I were to cover up this part of the problem and just give you the integral, the indefinite integral of 3x squared, you don't know if I'm talking about f of x or g of x, or even some other, like, you know, any constant like you want. You just don't have enough information. So that's why we say the integral is x cubed plus c to cover all our bases there. And so if you want to figure out what c is, the person asking you the question would need to give you more information. And they normally say like, it's normally called like an initial value or just like something like that. They'll say like, you know, it should pass through the point 0, 1. And so if you know y equals x cubed plus c, you plug in 0, 1, and you can solve for c. So in this case, c would be 1. But that's why we need the c, because when you take the derivative, the constants all zero out. So if you try to reverse that process, you're not able to get that information back. Never forget the constant c, calculus rhapsody. And so yeah, Jasu was mentioning how this works for definite integrals. Excuse me. We actually don't have to worry about it for definite integrals because I'll write it in general, I guess. From a to b f of x dx. So we can definitely say that the integral of this thing is capital F plus c. But when we evaluate it from a to b, the c's are going to cancel out anyway. It doesn't actually matter. So, oops, f of b plus c minus f of a plus c. And so we get plus c minus c. And so those are just going to zero out anyway. So that's why we only need to worry about it for indefinite. So I hope that makes sense, Ved. Let me know. Heard the Rhapsody group of high school students parody Bohemian Rhapsody themed around calculus. No. Calculus Rhapsody? Let's see. Hey, Shug. There are no numbers. No, just fancy letters and stuff. Applications of integration? That's kind of a tricky one. That's kind of like general, I guess. XYZ beats. Love you too. Like what's a common application they asked? They normally grill students on, like, you can talk about like arc length, I guess, but like, do any of these are any of these topics what you would want to talk about? XYZ beats, arc length, surface area, center of mass, hydrostatic pressure, probability, or I guess work. There's also work. I want to listen to the song though, as well. Oh my god. This is terrible. I think I prefer the Bosano Wires transfer out. Oh my god. I hope your day is going well, Shug. That's no, oh my god. Oh yeah, Shug. This is terrible. No, I think the Bolzano wire stress wrap is better. That's a Guitar Hero guitar too. Okay, I can't take this anymore. I want to listen to the Bolzano wire stress rap now. It's been a minute. Like, dude, this one, I don't know. It's just acapella. I just want to get to the word down with that part. Oh, it's so bad. Oh, about plus C. Okay, I can't take any more of that. Yeah. Like, are those his parents or something? I want to hear one more. 16 years ago. It really looks like it too with the resolution. The professors? Okay. We're about to get on them. I love how like the woman is so psyched and the dude is there because he has to be there. Also, there's the derivating song parody of Levitating. Oh, really? Oh, like the Kendrick Lamar song? I could see that one working. Oh my god. Are you down with that? We're down with that. 16 years ago, you just got into secondary school. Oh, I gotta get the music. The actual music playing again. Yeah, I don't like. How old is YouTube actually? How old is YouTube? 20 years. February 14th, 2005 is when it started. Hey, you're gonna be seeing this all day. You're welcome, Shug. I had 2007. I don't know. I remember just hearing something about the first YouTube video ever being a guy at the zoo. I thought that was 2007 for some reason. I think secondary school for me, only like 14 years ago when I entered it. It was a dating website. Oh, I think I've heard that. Oh, you have that YouTube book. Wait, you were born in 98? I was born in 97. Secondary school is high school, right? Hey, Rayon? I'm doing good. How about you? How do you start it so much earlier than me then, Joseph? I don't know. Does the university accept JE Merce? Depends on the university. Oh, Ved, if you want to, I dual stream to YouTube and Twitch. If you want to show up in the other, or if you want to be in the other chat, that's the Twitch chat. You have an exam and it's 3 a.m.? Yeah, you should try and get sleep, dude. Socials? Oh, honestly, I really only have like the Discord server. I do have a like a Don Factorial Twitter, but like I actually did reply to one tweet, so I had I have actually used it besides just like lurking. Actually, ooh, if syntax error shows up, I need to show him something actually. Because he asks about a delay differential equation. Someone on Twitter, Fizbuzz posted it to Twitter, and someone actually like solved it. Uh, I can show. You want to see? Yeah, sure, sure. Let me find it. Dude, how do you use this stupid website? Okay, yeah. Uh, okay, so yeah, so this is Fizbuzz originally posting the delay ODE. F prime x equals f times f of x minus 1. And he got this reply from this person. And he actually wrote up this actual like short paper on it too. So I guess I could take screenshots of this and put it in the Discord too. But I'll show it on stream here like quickly too. You skipped grades, that explains it. So yeah, I don't really understand what all this person did, but it looks pretty legit. Problem with your recommended for limited but interesting problem with calculus. Honestly, just pause on my notes. They have a bunch of both the example problems are good, but they also have the practice problems and the assignment problems. So there's plenty of things to do off that site. And then just to show everything, Fizzbuzz posted this like follow-up too. It's actually this is probably worth just posting in the Discord, to be honest. You know what? Should I just do that now? Because actually let me. I think Twitter is really annoying, and it doesn't let you look at tweets unless you're logged in. And so this is probably worth compiling into a couple of screenshots. I'm just gonna do that quickly now anyway. Post them into the Discord. Screenshot. Oops, not that. Screenshot. Can I? Okay, copy. Copy. Okay. All the screenshots are in place. At Sandom and anyone else who was interested. The delay differential equation syntax error posted the other day. BizBuzz posted it to Twitter and got a really in-depth response. Screenshotted here for those who can't see the tweet themselves. Okay. Non-traditional. So like, I assume just means like a non-traditional school. Or like a non-traditional student, rather. I guess it could be age, but it could also be other things, I think, too. Heaviside? I honestly, I have no clue. That was the original problem that Syntax posted. The solution that the person posted was it involved Fourier transforms and Lambert W. So I won't really be able to follow it. Okay, so we're going to have a contour. I should draw it in a different color. We're going to do a semicircle in the upper half plane. Oriented like that. We have two poles. One for the bitches, one for the hoes. At IA and IB. And I guess we can have C1 and C2. And so the integral around all of C is I'm a B. 2 pi I times the sum of the residues. Oop, not that. Leaking my Discord screen. All the people I wave hello to in the server. Gotta keep that a secret. 2 pi I times the sum of the residues. How do we... I'm not strong on... Finding the residues. 2 pi I times... So we need to find the residue about IA and IB. How do we accomplish that? Ooh. Yes, they're poles. So we get to use nice formulas. Do you know 69 squared and 69 cubed do not contain the same number, but other squares and cubes do? Like the same digits? We have to investigate this. 69 squared is 4761. Whoa, they don't contain the same digits. That's a very specific thing to realize. That's the type of math fact I can really get behind. I like that. Yeah, so Fenvox, we can use the formula that you were really liking. The n over d one. N prime over d. U. Ha. Wait. N over d prime. Hooray for 69. True. Oops. So just doing this in general, the cosine stays the same. The derivative of the bottom is 2x times 2x, or 2z times 2z. So 4z squared. So the residue, Doug's I should have gone with 69 instead of 42. True. He should have. Cosine. Oh, dude, we're gonna get KIA. Actually, no, either it's KIA or we're sponsored by Kia. We can choose either one. It's a negative for a squared. Cosine kib for b squared. Those are the that's the result of the integral, I guess. I should probably be specific about what f of z is. Oh, I did this wrong. Because I wasn't specific about what f of z is. Okay. Let's do this the right way. So I was supposed to consider e to the ikz over this. So too obvious. Too obvious. Okay, and then so that means we get still a minus sign. E I well we're getting two i's. I. E to the negative KA. We're no longer sponsored by Kia. Sponsor lost. Something about this feels off. So they give us k is greater than 0. How does k affect this? Oh yeah, if k is less than 0, you just do the bottom contour, don't you? Like the lower half plane? Yeah. Probably. Wait. Ooh. Does the N of Z thing... Okay, it's only a simple pull. N and Z don't have to have the degree thing. Hey, Numerous Taylor, welcome in. It's this book. 69 is the last factorial calculated? By who? Nobody's buying key arcanite, some guy solving the integral? Whoa. I think if I was sponsored by Kia, I would move a lot of cars, okay? That'd be a very successful sponsorship, I'm sure. Everyone in chat is gonna flood to the nearest car dealership to buy a Kia, okay? So here's the thing, aren't I getting 0? Because for cosine we take the real part, and the residue, and the result of the integral is purely imaginary. Wait. No? Yeah. Yeah, I think I get 0. And I think that's okay. Because we're taking the real part of this thing. So I'm saying 0. And you can't stop me. Did Fenlux and I do part C? I don't remember. I think I remember choosing part C. I don't know if we got time for it. Let me look at our notes. Oh, I chose part E, but we didn't do that. Okay. How did I get 4z squared on the bottom? By doing it wrong. That's how I got it. Thank you. It's a product rule. It's 2z plus 2z, which is 4z. No, it's not. Bleh. Derivative of that times that. Oh my god, I need to. Okay. 2z times z squared plus b. I just did the derivative completely wrong. That's what I should have gotten, right? and I suppose this cleans up. It's probably worth doing. 4z cubed plus 2a plus b z? Thinking. Yeah. That seems better, question mark. Squares on the A and the B. There sure are. Thank you. Ugh, okay, so that's more annoying to evaluate. Does this fit over... No, it doesn't. Okay, fine, stay there. See if I care. Get e to the minus ak over I cubed is minus I. What an annoying number. It's still purely imaginary, is it not? Because I can multiply by I over I. Oh wait, but that's gonna flip this thing to being real. Interesting. Okay. We can simplify this, can we? More than I did. Ooh. I made an oopsie. That's a minus. So 4a cubed minus 2a cubed is 2a cubed minus 2ab squared. I'm going to check this in Wolfram. It's an even number, isn't it? Yeah, it is. Of course, I feel like they intentionally made that one an even number so they don't have to provide answers. Okay, now the one for B should look very similar. Like I should be able to just figure out what B looks like. We just replace certain A's with B's. It's going to be 2b cubed, or not to be cubed, minus 2a squared b? Hey, Kitu. Oh, I can't do this one. Oh, maybe Wolfram Alpha will do it. There's 3 different constants. It may hate me. So I'm saying my answer is the real part of this, which is it's purely real. So Take this thing, cross out all the i's, and make it negative, is my answer. X. Cosine kx. X squared plus a squared. X squared plus b squared. Squared, yep. That's how you spell that. If I take away the K, will From Alpha be less angry at me? Ugh. That looks pretty close to what I have. You get a common denominator. Dude, I wish you'll give me in a different form. Okay, I guess it's probably worth the effort of making my answer look like... making sure it actually does match. Missing a squared in that first denominator. Thank you. That's already real. I'm not going to write the real on the outside. Hey, Burbaki. Discovered a truly marvelous technique to compute all integrals, which is common as too narrow to contain. Classic format. Well, so grad school starts September 22nd, but it's a month plus a week until I move. Okay, I think it matches. Nice. That's basically what I did, yeah. But yeah, I filled out an application to be a TA in the general like math department, and I'm working on one for the computer science department. They both have like things on their website saying that the students in their department get first priority, and the students outside like are very limited that they bring in. So it's not super likely, but I'm trying to do that anyway. Oh, Central. Thank you so much for the raid. Dude, how much did you sleep last night? Hey, Prio Drill. For anyone who's new here on Central's End, I'm Don. I'm a math nerd, so I actually do like math help streams. And I do studying when there's any question from chat, but I do also like games like Daisy, like Central does, and so I play that on stream too sometimes. You haven't slept? Oh my god, dude, get sleep. Yeah, Central. Thank you for the raid. Inno's here on my end. Central's an old friend, so if you're into Daisy, go throw him a follow. You need sleep? I think you do. Let's. My very old friend. And annoying. With Daisy, my favorite map for Daisy, if that's what you mean, is Namalsk. That's usually what I'm playing on stream. But right now, day one Namalsk is kind of dead, so next time I stream it, I'm probably gonna, unless it comes back, probably do like Deadfall or Cherno or something. What I do doesn't qualify as playing Daisy. It's kind of true. 2G by applying the power reduction identities. I didn't even see what the G is. Oh my god. You could. It'd be really annoying. Well, like, so right now I'm studying something called complex analysis. And doing integrals with that in preparation for grad school starting in a few months. Oh yeah, Central. Yeah, I would love for you to help me out with this integral here. I could really use some pointers on it. Oh, you sure? Yeah, I'm sure. Oh, okay, yeah. I'm sure you took one look at it and you knew exactly how to do it. You'll confirm? Okay. um, this factors, right? Oh no, it doesn't factor. That's annoying. I guess if it did, well, I don't know. 16 minus 20 over it. That's true, Zach. Yeah, just not easily factorable. Oops. -2 plus or minus I. Are those the crosses that Jesus died on? These right here, yeah. Oh, those crosses, yeah. It's actually all about calculus, the Bible. Okay, so x cosine kx over, you prefer Scientology? Oh yeah, I'm sure you do. Oops, this isn't it. It's x minus -2 plus I. X minus -2 minus I. Never speak to anyone ever again. Sign me up. Yeah, dude, you get to hang out with is Tom Cruise the big celebrity who's into Scientology? I forget who. I think it's Tom Cruise. Yes? Yeah. You call him Tommy C. You guys high five each other when you see each other in the Scientology halls. Varun Lau, you want to integrate x to the power of ln x over 1 plus x squared? That looks like a competition integral or something. I don't think I can do this. Probably need like Feynman's trick or something. You leave me alone now? Alright. Go to sleep. You get cranky when you miss your nap time. And you join cults also. You need food? Yeah. Hmm. I'll try that substitution. It looks like too much work. I'm just not going to do it, but we can at least look at it that far. Yeah, I don't see what to do from there. All right, good night. I'm just not going to do it. um Okay, so we have an x in the numerator this time. Does that affect anything? Probably not. I think we just use the same technique, I hope. I think. Um, N of z over d prime of... what am I writing? Hey, Neon. Okay, do not forget the product rule. This product rule is a bit easier, though. We have plus 4, plus 4. Plus, what? Plus 2, which is 4. We have plus I minus I, which is 0. Okay. And so n of minus 2 plus I over d prime minus 2 plus I is annoying. That's what that is. Ugh. Minus 2 plus I e to the I k minus 2 plus I. 3 plus 3 is 6. 4 plus 3 is 7. Gabe? 2 plus I plus 4. How does that work out? Get a go. Thank you. E to the minus k, e to the minus 2ik. This is so tedious. We get negative 4 plus 4 is 0 over 2i. Why do I like math so much? Just kind of, for whatever reason, when I see math actually be useful for certain things, it just kind of gets me excited, I guess. It's hard to explain, but like, why is anyone interested in anything, I guess? Some people really enjoy figuring out how cars work and working on cars. I just enjoy working on math, I guess. Thank you, Gabe. Hope we have a good day. Here's probably the challenge and solitary nature. Ooh. Oh, you know what? Numerous Taylor, I forgot you were first time chatter earlier, and thank you for the follow before too. I didn't say thank you. Whenever I do see first time chatter, if I'm not scatterbrained, I like to shout out that I'm not the only person on Twitch who does math streams. So if you're interested in like this type of stream in general, make sure to check out more people than just me, because I'm just one person. There's a whole like little niche of us. What type of math are you into? So I'm distributing the 2 plus I to these e's, and I'm trying to do this in my head. It's going to be -2, but the 2 will cancel with the bottom, and the negative, I'm going to multiply by I over I, so the negative goes away too. So it'll be I e to the minus k, e to the minus 2ik. But there's I kind of have to break that out too, unfortunately. Maybe I'll do that mentally. Stuff related to physics, currently going through differential forms and that type of stuff. Ooh, cool. So yeah, I like applied math, and I've taken an interest in physics. So I actually literally just wrapped up a reading group on general relativity. And last year I did one on E and M. I used to not like physics at all, but studying E and M made me actually really like it. I still can't really get into mechanics though. Applied math versus theoretical physics. Fight. They're pretty different things, to be honest. Like, the applied math that applies to physics is usually just called physics. There is mathematical physics, I guess, too, but you know, we can love and not fight. That's also allowed. E to the positive k this time. Okay, so super neurotic, so I feel like I need to have the rigorous definition that I'm saying before I can move on to applying it to physics stuff. That feels like it would slow you down if you're doing physics. Considering like they usually play fast and loose with the rules of math over there. It does? Okay. But if it makes you enjoy it more, there's definitely nothing wrong with that. Okay. So what did I just do? Oh my god, I hit... Oh, I hit Windows key instead of Control. Well, there's your problem. Okay, so we started with a cosine. So we need to take the real part of this shebang. Can I do this mentally? Do I have the raw intellectual power? I don't think I do. This is a lot of stuff to get... Like, I have to do Euler's identity in my head on this. Let's see. Let's try. Okay, so this I goes away. minus 2 pi e to the minus k. And then we'll get a, from this we'll get a cosine of 2k. That's all from this first term. Now from this term, the fun part about physics according to me is how you can work backwards to math and suddenly life makes a lot of sense. In terms of like the motivation for why we study certain types of math. Okay, so we're gonna get a minus I sine 2k from that term. But that gets multiplied by the I out front. So it'll be positive sign. So plus pi e to the minus k sine 2k. Yes. Okay, now we work on this term. We're slowly working our way through it. Well, this term should look the exact same as this term. Oh, are we getting cancellations? No, we're not. Those two terms look the exact same. The only difference is the sign in front flips and the sign of k flips in that one piece. So we get plus 2 pi e to the positive k cosine 2k. And this term looks almost exactly like that term. Okay, this looks stupid. Is there a less stupid way to make this look? Applied math win. Zach is just calling it. You know, physics is just really applied math. Like, I guess at that point you could call almost everything applied math, though. Because, like, chemistry is applied physics, right? Okay, well, this answer looks kind of stupid. Let's go, let's have a Wolfram check it. X cosine kx. Maybe we'll make that an A. Huh. X squared plus 4x plus 5. Chemistry is applied nonsense. Feels bad. Oh, it's kind of like my answer. It's hard to tell, though. If I let k equals 1 in my answer, I guess that's how we check. Two pi e to the minus 1. Oh, nice, Jason. Thank you for the kind words. Good luck with your studying. .67. 2.01. Bruh. I messed something up. You've heard Landau's classical mechanics is good for someone who normally doesn't care for classical mechanics. Short, dense, and interesting problems. Oh, nice. Math is applied repo. True, FA. I want to play more repo. That game's fun. Fields arranged by purity. Oh, I hope you're doing well, by the way, FA. Sociologists. Oh wait. So least pure is on the left, most pure is on the right. Sociologists. Just show that one to Shane already. Sociology is applied psychology. Psychology is applied biology. Biology is just applied chemistry, which is just applied physics. It's nice to be on top. Oh, I didn't see you guys all the way up. I want to post this in Shane's Discord. Ugh. Yeah. Repo's addictive. It's a great one, Zach. I appreciate you, FA. This is so much math to like check. Where did I go wrong? Yeah, between psychologists and biologists, I had one pre-calc class in college. It's all gone now. Yeah, I mean, I like math, but I definitely cannot argue that you need it in your daily life. So, are math questions really about identifying the underlying pattern/idea rather than the concepts? I think a good math question is about that. I guess it doesn't have to be. What about computer science? I guess you'd call that applied physics also. How many even numbers can be formed? Wait, how many even numbers can be formed where the number should be even? I don't think I understand that question, WizKid. Yeah, sorry, I can't figure out what that one will be. What did you study, FA? Maybe both psychology and biology or something? How many even numbers can be formed when the number should be 5 factorial? Well, 5 factorial is an even number. I don't know. I think I'm still misunderstanding. That question still doesn't seem phrased quite right, though, WizKid. I don't think I understand. You're an occupational therapist? Oh, nice. It's funny, I've actually literally been doing speech therapy for the past like month or two because I've been having like issues with losing my voice. And that's sounded like the occupational therapy like office. I've seen easy integrals and I see crazy integrals. Like when you're dealing with maybe I'm wrong, isn't solving math more like finding clues about what works and how would one proceed? Yeah, like the idea behind the problem solving right now is like the chapter taught the pattern of how you solve this type of problem, and I'm trying to drill through problems that follow that pattern to like learn it better. How many even numbers can be formed when the number should be including 5 factorial? I'm sorry, WizKid. It's like I that still doesn't quite make sense. Like if you start with 5 factorial, that's I think 120 if I remember right. I could actually calculate it, but like any multiple of 2 or any multiple of this, it's already even. So any multiple of that would also be even. So I'm really not sure. Only 5. Okay. So it would like I'm still not sure if this is like what the question is asking, but like you can form any like if you need it to be multiple of 5 and even, you take 5 and multiply it by 2 times some number that I called L. Maybe K is better. Where K is any integer. So there's infinitely many, I guess, but I feel like I'm not understanding what you are really asking. It's like you make 10, 20, 30, 40, etc. But I feel like I still don't have the right version of the question yet. This problem looks quite complex. Oh yeah, I made a slight mistake somewhere in this, FizzBuzz. And I need to figure out where. It's just that it's so much math that like I don't want to look for the error. The answer is about 2 point, or like I tested with k equals 1. I'm supposed to get about 2.01, but if I take my answer and say k equals 1, I get 2.67. So I made some small mistake somewhere. I had apparently made a cheat sheet containing various integrals that were solved, all the tricks and approaches to integrals. Some ended up helping me, but now I think about it, probably wasn't for the best. No, making a cheat sheet is a great way of studying. It makes you kind of think critically about the content that you've learned. Like you don't even use the cheat sheet, just making one is a legitimately good way of studying. Because it helps you organize all the tricks and stuff that you need to know to get through it. Oh, I see. 5 is one of the digits. Okay. So how many digits in total does it have to be? Okay, that's making a lot more sense, WizKid, but like how big is the number? Normally they say like less than 1,000 or something like that. Okay, perfect. Okay, so let me rewrite the question that you're asking just to make sure that I have it. That I'm understanding you. How many so how many 5-digit even numbers can be formed? And 5 has to be one of those digits. Oh wait, well actually ooh, wait. Is it any 5? Okay, no. So does the number have to include the number 5 or any 5-digit number? Like if we have 1, 2, 3, 4, 5. I mean, this as one of these numbers has to be 5 somewhere in here in this 5-digit number. But is that correct? Yes? Okay. Um, so I think how I would think about this is try to get every even 4-digit number. Like let's just take a random 4, 8, 7, 2. So get every single 4-digit even number, and then it's just a matter of inserting 5 either here, 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 or here. So it's going to be a little bit more subtle than I'm making it here, but like we're basically going to count every 4-digit even number and then multiply by 4 to reflect the 4 choices of where the 5 can go. The catch for this problem is we're gonna have to do it separately for 1-digit numbers, 2-digit numbers, 3-digit, and 4. It's like we have to do this in separate cases, I think. But we can do that. So let's start with 1-digit. Actually, for 1-digit, we have to contain 5, and 5 isn't even, so we get none. It's not possible to make a 1-digit number that fits the criteria. For 2 digits, well, it has to be even, so it has to end in a 2, 4, 5, or sorry, 2, 4, 6, or 8, or 0. And then the only other option is for the 5 to go in front. So it'll be 5 and then 0, 2, 4, 6, 8. So really we just have 5 options for 2-digit numbers. Now for 3 digits. We'll think about 2-digit numbers. This can be any number. Oh man, do we get cases now? I don't know bijection rule. Yeah, and it's probably the slow way of doing it was kid. I'm not very good with counting though, so number options. Oh, that one. Is it easier to count the ones that don't work? I misspelled your name, I just realized that. Uh delete gaming. Uh, I don't think so. That question looks pretty difficult. On Janie, I definitely cannot do that question. Sorry. Uh, WizKid. So, uh, I'm trying to think about the way to do it that you said for this question here. And I'm not sure I know how. I can't really figure out how to count the the bad cases. Um, so yeah, was good. Like, I guess do you want me to see it doing this like, or trying to do it this way, or just want to drop it? And I'll move on to a different question. $15,840. Maybe I don't know. It sounds like WizKid is just has tapped out, so I'm not going to bother trying to solve it. I don't think. Oh my God, send. Just post it once, please. Uh, Janie's asking about limit definition of E. Silverbird. That's problem, or there's been a few problems that have been thrown out, but I know I know the problem, like just like counting in the good cases. WizKid wanted to do it by doing total cases minus bad cases. And they seem to have just, I don't know. I think they'd rather just drop it. So I yeah. Um. I and so on Janie, for the limit definition of E, I think it's more of a definition than a proof. There's an interpretation to it. And you could take another definition of E, I guess, but um, I'm trying to find a proof of its convergence. I'm trying to find something that'll help me out here. Um, yeah, Vinesh, I can do it. But I'm looking at a different problem now. Sen, I think the answer to your question, if there, that's kind of the wording of that is really annoying. There's been a couple questions that have been asked all at the same time here. So I was trying to quickly figure out the question that Sen just posted. Isn't the direct approach easier? I don't know. The person who asked it doesn't want to talk about it anymore, so I don't care enough to solve it either way. If they use 3089 digits, I think that means it goes to 3088 as a page number. No, I think they go to 3089. I think you would, but it ends on an odd number, so it'll still have a backside. And so I think you do 3089 plus 1 and you divide it by 2 because they print it double-sided, presumably. So 3090 divided by 2, I think is the answer, but the wording of that is really tricky. Um, but yeah, and then Janie is asking about the convergence of the limit definition of E, and I don't know that I've actually done this exactly. And so I'm trying to work through what this is doing here. Is the sum of 3 prime numbers equal to a prime number? No, 5 plus 3 plus 2 is 10. That's not prime. Yeah, I don't understand what this article is doing right here. Is there a different one? Uh, it's a Janie is asking why the limit, like the limit, that definition of E, why we know that converges. That's what the question is. Oh wait, maybe I have done this before. If you use the binomial theorem. Okay, yeah, we can do this with binomial theorem. What's wrong with it being a Taylor expansion? No, it doesn't. You can define derivatives without E just fine. Obi, I think Janie wouldn't like that because we're using ln. Unless you're using a different log base, I guess. You can this does not use E anywhere in it. The Taylor expansion doesn't use E either. Taylor expansions don't need E inherently. Yeah, but maybe the even simpler way of doing it is to use a different base for a log. Well, no, I think Janie wouldn't. Oh no. Uh, I I think that they wouldn't like the presumption that they're asking if the limit does converge. Just setting it equal to L wouldn't be good. I'm like 99% sure that the Taylor series doesn't need E to be defined. It's just like derivatives of a general function. It's not e in particular. So if you want to show me where you think e comes in for a Taylor series on Janie, like link me to something, but you don't need e to define a Taylor series. You just talk about general derivatives of a function. With the limit definition of a derivative. That doesn't need e. Prove the power rule? Uh, oops, sorry, this isn't the... There we go. You're saying that this relies on binomial expansion for that? Is your point? You don't need e to do the binomial expansion. Yeah, this website does it. They don't even do a binomial expansion. They just factor in a minus b out. You know, they just like factor one thing out. As long as it's non-negative integer for the exponent. Hey, this isn't using binomial expansion at all, actually. Why they do it for negative integers? You can use the quotient rule for negative integers. For rationals, You can use implicit differentiation. And then for arbitrary real exponents. Ooh, that's where they're using E there. Presumably, you don't have to use E for that though. Like, could you do 2 to the n log base 2? No, there you'll still get an E if you use 2. Yeah, I guess on Jane, the answer to the question is I don't know. I haven't really dug into this exact topic in calculus before. I'm sure there is a way where it works, but I don't know it exactly. Uh, so Janie is asking to uh, prove that the limit of 1 plus 1 over n to the n converges. So we haven't defined E yet. And Anjani takes issue with using like a binomial expansion because that's a Taylor series. And the claim is that the power rule for an arbitrary real number requires E to be defined. So trying to avoid circular logic. And yeah, numerous Taylor. Anjani is pointing out correctly that the first 3 don't cover irrational powers. And so doing that in a rigorous way, I don't know the answer to that offhand. I'm sure that someone has done it somewhere. I never have really looked into that question before for myself. Because there's like, I think you can also define E as just whatever function is its own derivative. And maybe you're okay in that case. And like you can get to the power series using that as far as I know, but yeah, I don't think I know the answer to your question on Janie. I think you got me here. uh I'm going off things I heard on Janie. I don't know. I think you're gonna have to try someone else. You're asking about things that I don't know at this point. What's the question, Atharv? Oops. Sorry if that made a noise in my mic. Okay, I made a small mistake somewhere in this work, and I still want to find it. I studied applied math, then. That's about differentiation? Oh wait, G prime. Oh, okay. Yeah, I think I can do that. It's gonna use a formula that's not very common. I need to look it up. Math isn't for people. That's fair. So not everyone is gonna like math. Okay, so I think this problem we need this. Oops. We're gonna need this formula here because we want to basically find the derivative of the inverse. So g prime of 1 is equal to f inverse prime of 1 is equal to 1 over f prime of f inverse of a. Oh, well, we can't really invert this, though. Is this fun? Oh, man, is this thing even actually helping us? That's so annoying. I forgot there... The answer is 2, apparently. Okay. Uh, is this over 2 in the exponent or outside? Like, is this it? Okay, so that makes a really big difference. I thought it was on the outside. Uh, then yeah, I think on Janie's on the right track where if we want g prime of 1, we can make f of x equal 1 and figure out x by guess and check. Because x equals 0 will give us what we want. But there's no way to actually like solve that. You just have to notice that 0 would work here. So that means f of 0 equals 1. We know that much. So f inverse of 1 is going to be 0. And now we can use the formula that I wrote above. 1 over f prime of 0, just plugging in 0 for f inverse of 1. So we just need to figure out what f prime is and plug in 0. Plus a half e to the x over 2. Hey, Vraj. F prime 0. It's just going to be a half. So 1 over a half, and so that is 2. Nice. No, I don't do this every day. No, no worries, Atharv. I really don't want to check this work. I just made some small mistakes somewhere. Thank you for the kind words, Seon. Let's just do part D. Because I don't feel like checking work. Oh, yeah, sure, Papadoria. There's nothing else from chat, so I can work on a question from you. Hey, RG. I'm not solving an entire worksheet for you, no. Problem is bigger, that's the part you're stuck on integrating. I'm not doing your homework for you, RG, no. This isn't possible with normal techniques. Just out of curiosity, what does Wolfram Alpha think of this? Feynman's? Maybe Feynman's is possible somehow. Yeah, this is in terms of an integral still that Wolfram Alpha gets. There are some integrals that Wolfram Alpha doesn't know how to do, though, for difficult enough integrals like this one probably is. This one is close enough to the Gaussian integral that I wonder if someone's posted on Stack Exchange. I'm going to search for it with E because I think that's what people are more likely to be thinking about. Oh, power series. That's an idea. Wait, what? They don't provide any clarification on that. That's kind of interesting, though. That's a fact, I guess. The other parts is valued at A equals 10, 100, and 20, 25. The substitution GLS, T equals X to the N. RG, I'm not doing your homework for you. Oops. Yeah, Zach. So just use the version that was posted in the Stack Exchange. This might apply to the problem at hand. T equals x to the n. If x goes to infinity, so does t. I think the bounds stay the same. Um, how do we deal with x to the n minus 1? Whenever n gets factored out? Okay. Well, that's where I'm getting confused. Yeah, but we still have an x, so that's not really solving our problems, or like I didn't know how to deal with that. Are we gonna say x is the nth root of t? I guess. Huh. And that's just the gamma function. Really? Oh, yeah. We have 1 over n, they have z, but that matches, yeah. Okay. I guess we have the factor out front too. Uh, but maybe that's why it's n plus 1 divided by n? Oh, that's like where the division by n comes in some way. So I wonder if the same idea can apply to Papadoria's problem. Like, can we squeeze a gamma out of this thing? The incomplete gamma function. Ooh. Let's see what that looks like so we know when to stop. Hmm. These small gamma for it sometimes. Oh, for the lower one. Huh. Okay. Yeah, let's see if we can get this. So yeah, it looks like a good first step, Zach. Yeah, that looks good. To me, at least. And so presumably, we probably want to do x cubed ln 10 in our sub. I assume we want to include it. If x equals a, t is a cubed ln 10. We need to do more work. Hopefully this part still works okay. Uh, oh wait, no, that's still, no, this part is easier because that's just a minus t. And then we're dividing that out. So we need to find x squared. We'll do that in a separate step. We'll need the incomplete gamma function. Okay. So x squared is equal to t over ln 10 to the 2/3. If you let a equals 0, you get a gamma. Okay. I guess we can simplify the ln 10s a bit. That'll be next step though. Username checks out. It does. Joseph integrates. It's like a Zach integral. Hey, gold. It does. Zach is guiding me through this, thankfully. Because I sure as hell don't know what I'm doing. So we need to shuffle the exponent of t around a bit. You want to have an integral? That'd be cool. So we have negative 2/3. So it's going to be positive 1/3 minus 1. And then that's going to match. Oh, we can simplify the ln's. Of 1/3 comma the lower bound. So that's a thing. Integral found with an e to the power is now known as a Zach integral. That's a good choice because that, you know, will come up a lot. So if you want to get your money's worth out of the integral, it's a good way to do it. So can we actually evaluate this? I guess is the next question. Yeah, what's the question, Daksh? Holomorphic extension. Oh, I'm really glad they're using gamma to mean two different things. The frickin' macaroni constant. There are enough Greek letters. We do need more ninjas. I completely agree. Hey, P. Vermi. Oh, that's right. We do have actual values. Oh, do you already know the answer, Doc? If you're just kind of asking me to challenge me, I'd rather not do it. I'm worried to help people out with questions they don't know how to do. So we still won't really have. Yeah, sorry, that looks like a bit of a pain to do by hand. Like you have two quotient rules. It looks like a lot of algebra there. So with the special properties they're listing, I'm not seeing any that would match what we have for 10, 100, and 20, 25. Syntax. This is the incomplete gamma function. This is the type of question that I feel like you would ask me. It came from Papadori asking about. Oh, I did it again. It came from Papadori asking about this integral here. And so thanks to a Stack Exchange thread and Zach, we were able to make this thing look like the incomplete gamma function. And we're trying to figure out if we can actually do something with that now. Because Papadori's next step is to evaluate it for a equals 10, 100, and 2025. But those don't seem to give us any special cases for the gamma function, so... or incomplete gamma function. For an A is a big number, okay. There was a section on asymptotic behavior here, I think. Ooh, this is the song. Oh, really, Papadori? I guess that's something. Perfect soundtrack, yeah. Yeah. I mean, so just Venegas are basically hoping to evaluate it at those different values of A. I don't know that we can do it, but presumably Papadori's professor didn't mess up the question, and there should be something that's possible. Wait another 100,000 years? Yeah. There you go. It's probably just going to be the brain of Papadoria's professor, who's known to give very challenging questions. Yeah, sure. This might be as far as we can take the question, or as far as I can. Never mind. And I saw your other question, syntax. I'll talk about it in a second. It is kind of interesting with the 10 and the 100 that 10 cubed ln 10. You could rewrite this ln 10 to the 10 cubed. Presumably you could simplify that in some way, right? I don't know if that really, I don't know if that's anything. I wonder if Wolfram Alpha does anything with the incomplete gamma function. You know, I doubt there's a button for incomplete gamma function, right? Can I just say capital gamma of something and Wolfram Alpha will know that? Let's see what Wolfram does with this. Oh, hey, it does know incomplete gamma function. Hey, here's an exact answer. No, it's not. I was just trying to meme it anyway. I'm not getting any inspiration from this. Is that Zoo Team Zoo? Hello, welcome in. Sorry if I'm probably pronouncing that wrong. You got it right? Oh, good, good. So yeah, I'm not sure what else to do with that problem, Papadoria, but I feel like that's at least made a little bit of progress there. Syntax error, I do want to talk about what you asked. You can type it there in the chat, or you can put screenshots and stuff in the Discord if that's easier. So basically why, like, you just submit this answer if he doesn't like it. There's some unknown method of simplifying more. Okay, that's something. But like doing it for different values of A makes me think it should be possible. Like, you know, there's no real difference in the answer for different, like, you're not doing anything different, just the very last step you sub different values of A. So I would think your professor is intending something to be done there. I don't know what that thing is though. It's like the are you basically asking like why exponentials are the solutions to like homogeneous differential equations? You get the same result? Okay. Yeah, Papadoria. Like that's my thought too, but I don't know how. In the way I think about it for like basically why E is always the answer to differential equations is E has the property that y prime equals y. And so just talking about first order only for now, um, if you encounter something that's like y prime plus 2y equals 0, you can be pretty sure that e to some power is a good guess. And if you go to higher order stuff, like if you take more derivatives of e, you're still just getting different like versions of e with more constants in front. And so I don't think there's a very good answer to it, aside from we can show that e definitely works, and then I think separately you can prove that the solution is unique. That's kind of my understanding of this. I wish there was a more clean way of showing, oh yes, this definitely should be E, but this is how I kind of, like, I start by thinking about this property and just kind of extend it from there. Maybe pull the Collatz conjecture thing is make us overthink, maybe. But like, yeah, I guess imagine if you actually did manage to prove the Collatz conjecture and your professor had to quit his job. That'd be an epic story. And you can tell that story when you get your Fields medal. You need to verify it indeed is true that it always is the sum of exponentials. Oh yeah, if there's repeated roots, that's where things get annoying. Because it's also technically true that sine and cosine, once you get into second order and higher, that sine and cosine might be involved too. But because of Euler's formula, those are really just E still. So I kind of don't have a very good explanation for it beyond what I've said here, to be honest. Like, maybe there is some deeper reason, but it kind of just really comes down to the fact that E has that really amazing property. Sambit, you have a quadratic that you want to factor? The Euler twin prime conjecture, Collatz conjecture, Riemann hypothesis gets solved. We'd love to see it happen. That would be cool. Sambit wants to factor... or at least like solve the equation, but I assume you're supposed to do it by factoring. And so whenever this number in front isn't 1, it's always more annoying to do. And so I personally do these with... you could just quadratic formula and be done. But if you want to be a bit more like elegant, I usually use the AC method. So what we do is you take 3 times 14. That's equal to 42. And when you think about numbers that multiply to 42, negative 42, I guess, and add to positive 5. Air conditioning method mentioned. Yeah. And so whenever there's like something that's not 1 in front, I set up the parentheses in advance, and I think about kind of what has to go where. So we need a 3x squared, and the only option for that is to do a 3x times a 1x somewhere in here. So we know that has to be true. We also know that has to be a negative 14. So the options in these other spots are 1 and 14 plus or minus, or 2 or 7 plus or minus. But I like the sound of 2 and 7 because we can do 7 minus 2 equals 5. So, ooh, wait, is this with fractions though? You know what? I think we need to forget about this because I just realized that this 3 in front is messing a lot of things up, actually. And we're going to get fractions. I would probably just quadratic formula this. Let's see what the answer is going to be, the quadratic formula. If it comes out to be clean, I'll go back and figure it out. But I think this isn't going to be easily possible with factoring. So minus b plus or minus square root b squared minus 4ac. 4 times 3 times minus 14. All over 2a, which is 6. You never try anything but the quadratic formula? I'd rather not use it because it's annoying, but you definitely have to use it sometimes. The question is wrong? Oh, what's the actual question? The negative root is weirdly close to pi? That's funny. Swagatika, if it's a question you need help with, yeah. If you're just giving me a challenge problem, please don't. So what's the actual question, Sambit? Okay, see you, Papadoria. Thank you for the question. You have a chemistry test and you're watching this? Well, good luck with your chemistry test. Switching away packing cylinders on a sphere? Oh my god. Oh, you need to complete the square. Okay. That's a different problem. You're right. Okay, so... Oh, this is an annoying one to complete the square with. So, completing the square, again, like this being a 3 here is really annoying. I always just factor it out from the beginning and just deal with whatever happens inside because the alternative is still worse. Usually. This one is just an especially ugly quadratic. And so now we want to do like a plus or minus trick. And the thing that you do plus and minus of is b over 2a squared. But since like I'm working only inside the parentheses, so I'm going to pretend like a is 1 here. So 3 on the outside, x squared plus 5 over 3x plus 5 over 3 divided by 2 is 5 over 6. And then you square that to be 25 over 36 minus 25 over 36 minus 14 over 3. And then if we did this right, this bit right here should factor as x plus 5 over 6 squared minus 25 over 36 minus 14 over 3. And I'm mentally multiplying this back out to verify we get this bit here, and we sure do. So I think we did it right so far. Now we'll bring the 3 back in and distribute it throughout all these. So 3x plus 5 over 6 squared minus 25 over 12 minus 14. Then we just have to group these two things and we're done. That's annoying to do. 14 times 12. I can do this. It's 12 square. No, it's not. 14 times 12. Ah. 168 over 12. 3x plus 5 over 6 squared minus 193 over 12. So it's a pretty ugly thing, but I think this is the answer here. A variable line drawn through the focus S of a parabola y squared equals 4ax intersects it at points A and B. Find the locus of the point of intersection of the tangents to the parabola at points A and B. What the hell? Yeah, I'm sorry, Swagatika. I don't think I don't know how to do that at all. Linear algebra was, here's how to do it. Here's the linear system of first order ODEs. So it has solutions of the form f of t equals e to the ta f of 0. To actually evaluate e to the ta, you can decompose a into Jordan normal form. Evaluate from there. Oh, that's cool, Fizzbuzz. Oh yes, Swagatika. I don't know how to do JE Advance, I'm sorry. I've tried these questions before. They're just they just use really weird and vague tricks that I don't really taught in America. Wait, so you can evaluate e to a matrix using Jordan normal form? I thought I've seen that you can use power series. I haven't seen that exact way of doing a system of differential equations. That's interesting. Power series is defined and then JNF helps you calculate it. Oh, okay. Something I'll probably try to learn about soon. It seems helpful. Okay, I think we might wrap it up here for the day. Yeah, let's wrap it up here, I think. So yeah, people here on YouTube, thanks for being here. I'm back on YouTube on Tuesday.